I haven't gotten a notification on my phone.
Setting up the meeting for live, and it's going. Little red line's almost there. Oh, I got the email, but now I gotta wait for the YouTube to actually show up so we can monitor the chat just on the in case somebody asks us a question. All right. All right, that's taking way too long. I'm gonna just close that out and hope that it actually goes to YouTube, and we'll just start talking.
Yeah, it does look like on YouTube. When I go to YouTube, it says that we're live now. So
Yeah. Yep. And I got the email that we're live now, so that's good. Anyways, welcome to UAB Data Science Club. Today, Ravi and I are going to talk about SQL. SQL is not a, I don't know, it's not a particularly sexy topic. But again, it kind of fits in the category of 80 to 90% of what you actually do when you're doing data science is fiddling with data. And so
yeah, I mean it's particularly necessary for data scientists to know that topic for several reasons. One reason is that your data set might be too large. That means that you might have a separate database where you are saving all that data. So you need to know how to access that database and how to find out which table you have stored the data, or which table you really need to conduct your machine learning, or create your machine learning model, or manipulate that data set. Uh, Secondly, I mean, it's also something. It could also be that if you are working with open source data sets rather than just providing a CSV, the open source platform where this data is available to you is in the form of an SQL database. So again, you need some knowledge and how you are supposed to access the database, how you're supposed to gather data from there, and and then once you have the data set in your scripts, you can start working on it.
yeah, absolutely. So all that being said, we will jump right into it. It's been a while since we've done a Kaggle tutorial, but they've got an SQL tutorial, so it's a good place to start. So we went to kaggle.com/learn. And if you go there, so let's see, we'll go from kaggle.com, and I'm logged in, so you can see some other stuff going on. But then if you go down to courses and then you scroll down, there is an intro to SQL course. And so that's what we're going to look at today. And so we'll just get started with this first one, this getting started with SQL and BigQuery. And in true Data Science Club fashion, we're going to skip the tutorial and just jump into the exercise. And then we'll bring back up the tutorial in case we we can't figure it out.
Yeah, it's not when if so it's not if when we realize that we should have read the tutorials, we'll go back.
Yes, yes, absolutely, absolutely. All right, so so now I have this going, and we scroll down, and so this is a Jupyter notebook that's running through Kaggle.com. It already has some data that it can pull from over here, and so this is Python here. Sorry, I have a small child and a dog in here talking, so pardon the background noise. All right. So first thing we're going to do is run this one. This is just for setting up the tools like the error checking and the exercise kind of things here, and then also importing some global variables from Binder, which Binder is a platform for hosting things like Jupyter Notebooks, public Jupyter Notebooks. Let's see. All right. So now here's where things start to get a little bit interesting. So from Google Cloud, we're importing BigQuery, which I believe BigQuery is a library for querying SQL databases in the cloud. That's my guess. We're going to use
Yeah.
this, so we'll see what that looks like when we get there. And then it looks like the client data set here, we can just specify by name. So that's nice. I wonder if that's because we have it already over here, or if that's because that's what the BigQuery lets you do. All right. So, all right, I didn't run that. Let's run that. So it'll be interesting to see how much of this is Kaggle dependent stuff. I'm not really entirely sure. Let's real quick Google what BigQuery is. All right, so BigQuery, Cloud Data Warehouse. It's a serverless, highly scalable, and cost-effective data warehouse designed to turn your big data into. Okay, so this looks like a Python. What we imported was a Python API to access SQL databases in the cloud. Does that sound reasonable?
Yeah, yeah. I mean, it's basically, I don't know why they already have the Chicago crime dataset, but if we didn't have it, my guess is that we over here in the client.dataset, we define the first the dataset that we want, or the SQL, sorry, not just dataset, SQL database that we want, and the second thing specifies which project do we want this database from. And then the first line is just basically that, and the second line goes in and pulls down that data.
All right. So, like Ravi, you mentioned at the beginning of this, I think I'm already at a place where we've got to go look at the tutorial, because it's asking us to figure out how many tables are in the Chicago crime data set. And so we know that we've got this data set. So we have access to an API reference of the Chicago crime data set. But I'm not really sure how to get there from here. Let's see. So let's see. We can use tab completion to try to figure out what's going on. Dataset.table. Let's see what happens if we do here. Nope, that's not it either. All right. Do you have any guesses?
Um, Now
Uh,
maybe we might. Yeah, let's go back to the tutorial. I think tutorial has one. I have it open up on my Mac as well, and I think we can use the
all right.
list command in the client.list tables.
Oh, list. So client.list tables. Okay. So if we come back here, let's see, what is our client? Our client is named client. Okay. So we go client.list tables.
Yeah, I think it's
What did I miss?
list underscore tables.
Oh, okay. Gotcha. List underscore tables. But this is an iterator, so it actually doesn't.
Yeah, so we can add it to a list, and then at the end of that we can do a dot length or something, or
Let's
dot
see.
len.
I think we can do like this.
Oh yeah. All right, so number of tables is 1.
No, correct. Cool. So yeah, I guess list doesn't have length as a parameter. You can pull out of it that way, but you can use the length function. All right. Let's see what if there was a better way of doing that than what we had. Okay, so yeah, it says use list tables. All right, so yeah, it's pretty much exactly what we had, but just broken up into multiple lines. All right, how many columns in the crime table have timestamp data? Okay, I think we got to go ahead and go back to the reference over here. All right. So yeah, I think we're going to need to have a reference to the table so that then we can do this table schema. I think that's the next thing we've got to do. So we know, let's see, so we've got, this is just data set. And then it's already telling us that the name of our table is crime. And then table dot schema.
Yeah.
All right. All right. So here we're doing 3 things. First, we're getting a reference to the table using dataset.table with the name of our table. And then we have to tell our client to actually go and get the table. And then after that, we can ask the table what its schema are. And we've got a few different things going on here, but let's see. We've got 1 timestamp, 2 timestamps. I think we've got 2.
Yeah.
All right. Now let's see. There should be a way of doing that with an iterator of some kind, but it looks like for the purposes of this initial one, they just wanted us to eyeball it, which is what we did. So that's fine. All right, so now create a map with a dot at each location of each crime. What are the names? We're not even creating the map. Okay.
Oh, we just need to find out those table fields, or yeah, 2 fields that we need to. So we need to go back to the schema,
Okay.
and there must be
Here's an X coordinate and Y coordinate. Oh, here's
yeah,
latitude and longitude. That's probably what we would need. Well, let's see. Yeah.
yeah, latitude and longitude should be good, and I think x-axis and y-axis should be good too.
So let's see. So this would be latitude. Okay. So that's correct. Now, again, we just eyeballed it. Let's see what they were telling us for. There are a couple of options, but the two of the fields are things commonly used to plot on maps. Oh, okay. So yeah, it looks like it would have been fine to use either one of those.
Yeah, we could have used x-axis and y-axis as well, I believe.
Yeah. All right. Now let's see. Look at a few of the values to see if you can determine their relationships. Okay, so the list rows command. What is that off of? Is that off of table? Oh no,
Yeah, I
column.
think.
It's like this. Here we go. Oh, and it's got a 2 data frame function. That's nice.
And then after that, we can get back into the familiar territory of pandas.
Yeah. All right. So let's see. So here we've got X coordinate and Y coordinate. Now, why does this say none? Let's look at 100. Here we go. So let's see. So we've got location, which is just a
Combination.
it's single representational coordinates. And then this X coordinate, Y coordinate.
Yeah, the only difficult thing with x coordinate and y coordinate would be the kind of map that you will be using. You'll have to be very consistent with what they had been using when they put in this x coordinate and y coordinate.
Yep.
Latitude and longitude is universal. So any kind of map you choose, uh, the size doesn't matter. You can use the latitude and longitude, and you both would be pointing at the same location on Earth.
Yeah. Yeah. All right. All right. Well, then I think we're pretty much done with this one. We've been talking for about 12 minutes. So let's at least take a quick peek at what the next one is here. Select from and where. Do you want to keep going or you want to just
We
do
can, yeah, we can take a look at this one as well.
you want to take a look at this one? All right. So let's, because these don't seem like they're very long. All right. So up until now, we've just been looking at the tables, but this is where we actually start to be able to pull information out of the tables. So again, we got to set up the tools, the learning tools. And then it looks like instead of Chicago crime, we're going to look at the open air quality data. And so they've already gone to the trouble of giving us a reference to our table and showing us the first 5 rows in a data frame. Okay, so that's kind of nice. All right. Interesting. Okay, so now we're going to start performing queries. So this is nice because this allows us to, if these databases are really large, we can select a smaller subset that we're interested in actually looking at. All right, so which countries have reported pollution in units of parts
PM.
per million? Set first query to an SQL query that pulls the appropriate entries from the country column. In case it's useful to see an example query, here's some sample code. All right, so let's just pop this in here. We know that this is wrong.
Yeah, so we need a select country.
Okay, so select country.
From, what's the name of the table? Okay, it already has BigQuery that dash public. Can we go up and check the name of the table?
Mm-hmm. BigQuery public data global air quality. Yeah, I think that's right.
Okay, Where? Oh, okay. Can we go, take a look at the table again?
Oh,
Where it?
where unit
Yeah, where unit is, I
equals
think.
ppm. Unit equals ppm. All right, let's give that a whirl. Hey, apparently US is the only one.
Yeah, it might also be just showing the first five values, and all of them are
Okay, so let's see.
US.
So if we want to
Yeah, I mean,
select,
so when we print, we can remove that head or add more values.
oh, because it was up here. Let's see. Because where do we do? Oh, okay. Because we're just doing the
Yeah, there's a five.
head, so it's going to default to 5. Okay. And I also added the select distinct.
Yeah.
So that's nice. All right. So high air quality. All right. So now we're going to make another query. And let's see. We're going to make another query. So select all columns.
So select star
Okay. Okay. So select
from,
all columns from the same database, right?
yeah, and we need to find the field name where we need to see the pollution level. I'm guessing pollution.
Okay. So pollution value.
Maybe value. Yeah, value seems the right
Let's
one.
try
So
value, where value equals 0.
yeah,
Okay. And then API request, run the query and return a pandas data frame. Okay, so that's up here.
yeah,
So
yeah.
query job, do they? Oh, okay, so we could do this query job.
Dot to data frame.
Is it anything capital or is it? No, it's not.
No, just an underscore after this.
To underscore data frame. And let's try that. Oh, and hey, that worked.
Yeah.
Well, that's nice. All right. And so what library are we using to do this SQL
BigQuery.
finale? We're still using BigQuery. Okay.
Yeah.
All right. So BigQuery is a Google specific thing, but the thing that's SQL, right, is this query language stuff, right?
Yeah.
Because
Yeah.
that's
And you
how,
do,
because you have used a good bit of SQL,
yeah.
right?
Yeah. And you don't really need to stick to this BigQuery tool. There are a lot of Python libraries that make advantage of an SQL. They have SQL APIs or SQL linkages, which enables you to run these SQL queries directly from a Python script. And once you have them, uh, a lot of them also have this to data frame function where you can convert it into a data frame. Or if not, you will get a result once you run the SQL query, and then you can use the pandas data frame to make that entire data set or resulting data set into a data frame. So, so yeah, I think we are going to stop over here, and the rest of the exercises we can do later on. Uh, I think William dropped out. His internet connection is acting up, but Yeah, if you guys have any questions, feel free to post them in the comments. You can come to our office hours or shoot us an email, whichever way you prefer. And we are going to see you next week with rest of the tutorials on SQL. Talk to you guys later.